Okay, I want to investigate time constants, and instead of showing inductors and capacitors separately, I just thought we'd show them side by side because these two components are really sort of like brothers and sisters of each other. They're very much related, although in a yin-yang sort of way, and we're kind of going to look at that and see what this actually means. So we know with inductors oppose instantaneous changes in current, and capacitors oppose instantaneous changes in voltage. So these are the two things that they do, um, oppose a change, one opposing a change in voltage, one opposing a change in current. The other thing we want to look at with these two things is they both store energy. The capacitor stores potential energy, and the inductor stores kinetic energy. Inductor stores energy due to the movement of electrons, while capacitors store energy in position of electrons on the plates. So I have a simple circuit here, and I'll show you the values I've got here for these two circuits, these two time constant circuits. They're both hooked to the same power supply, and we're using a single switch to supply power to both of them. Now we know the time constant for an inductor is L over R, and the time constant for a capacitor is C times R. So you should be able to calculate the time constants for both of these. And what you're going to find out is it's the same time constant for each one. So that means we ought to see something maybe equal and opposite happening to these two lights, these two light bulbs when we supply power to the circuit. So I'm going to turn on my electrons here so we can see them. And I'm also going to turn this from schematic mode to lifelike mode so we see what this would actually kind of look like if we had put it on a breadboard or wired it up. I'm going to apply power, and as you can see right now, before I apply power, I've got 10 ohms of resistance in the bulbs, 10 henries, and 0.1 farads, 20 volt power supply, and I have a switch, and my switch right now is showing infinite ohms. And this is something that a lot of people don't think about when they think about electric circuits, that really when you have a switch that's opened in a circuit, it's the same as a resistance of infinity, or at least something approaching infinity. So let's go ahead and supply power to the circuit and notice what happens to the bulbs in this. So immediately the bulb in series with a capacitor was lit up brightly and it went dim, and now the light for the light in series with the inductor was dim initially and got brighter over time, and now we've sort of reached a steady state current for this circuit, and the inductor is essentially out of the circuit. It's acting like a conductor now. It's not opposing a change in current anymore. There's even something more interesting that will happen here in a second when I show you when I open the switch up. But let's go ahead and monitor the current here. We're going to take a little non-contact ammeter and kind of move around and look at this. We got 2 amps, which is what we expect. We have 20 volts divided by 10 ohms. The inductor is essentially shorting now. It's not opposing the current anymore, so it's basically acting like a dead short. So Ohm's law is taking over, and we have 20 volts divided by 10 ohms. And of course our switch isn't offering any resistance at all. It's set for 0 ohms. The current over here on the capacitor side is 0 amps. The thing to keep in mind with capacitors is that the long-term current through a capacitor with a DC supply approaches 0. So It basically acts like an open circuit after a long period of time. So here we have an open circuit on the capacitor side, and for the inductor side we have a short circuit. This is another kind of an opposing view of these two components. One is a dead short over a long period of time, and one is a open circuit over a long period of time. And the capacitor acts like a short circuit during the first instant that voltage is applied to it, while the inductor acts like an open circuit during the first instant power is applied to it. So this is another one of those yin and yang things about these two components. Now what I'm going to do is open the switch up here, and keep in mind the inductor opposes changes in current. So this means that when I open the switch up, the current through the inductor should not change instantly, as it would if this was just a resistive circuit. The question is, if the current can't change instantly, where's it going to go? And we'll soon see. So here we go. I'm going to open the circuit, and notice that the current shifts direction and starts to discharge the capacitor. The original current that we had going through the inductor was coming from the bottom of the battery, the negative terminal of the battery, going through the inductor, back up through the bulb, and back to the positive terminal of the battery. The direction and magnitude of the current cannot change instantly. So what it did was shift it over and started pumping electrons into the upper plate of the capacitor, which was positively charged at the time. That just meant it had a deficiency of electrons. So this thing is now pretty much in, everything's died down. We pretty much got zero current for the whole system. Let's turn it on again and see what happens. Okay, notice our capacitor current is dropping, our inductor is increasing, and we have a constant 2 amps here. And at this point the capacitor is completely charged. Our inductor circuit will remain the same. The current through it will remain the same forever, or at least until we open the switch again. So I hope this sort of sheds a little bit of light on inductors and capacitors. I think a lot of people who study, when you go into a course and you study capacitors and inductors, one of the mistakes that instructors make is there's two separate chapters in most books on inductors and capacitors, and nobody seems to do a compare-contrast on these two components. I think it's very important that you do a compare-contrast, because this helps make some of the ideas gel in your mind when you see these two components side by side. One is a short over a long period of time, and a open during a short period of time, and the other one has the complete opposite behavior. One is storing energy in the form of kinetic energy, and the energy due to motion, and the other one's storing energy due to the position of electrons on these plates. So I hope you found this useful.